Hi, this is Dan White in the Product Platform Lab. I thought I would show how simple it is to build a simple starter model that just blinks a light. And this is very similar to one of the examples in the workbook, but I will actually make it a little even simpler. So if I just want to start with a brand new Simulink model, and I'll just go ahead and save that and name it just blink, because I'm going to blink a light. As you can see, I already did this once. So let's just, now it's asking me to save it. So let me call it Blink 2. Just so we're not showing the old model. So first thing we always want to do is get rid of this other model, and so that we can see our target definition block. That's always the first thing you want to drop down, because it defines what hardware you're talking to. In this case, it's the 9064. And you also need to find the bit file package that came with the RCPEK, which I can find here under example models. And then you need to put in the IP address for this particular target. We're kind of on a local subnet, and I can hit the connect button, and it'll ask me if I have a password set up. It'll ask you for that. But the connection is confirmed now because it pulled up the serial number. In this case, I want to auto-load at reboot and auto-deploy the model. So that means after it builds, it will automatically deploy it straight onto the hardware. So after I hit OK, it goes through the bit file a little bit. So since I know I want to write to some hardware, I'm going to go to the LHP block set, and actually I can go to FPGA-IO, and I know I want to write to a digital output pin, so I'm going to pull down that the DIO. Now, if I want to, I can search for the 94. Oh, if I type it in correctly, 9401 is the card that has the digital outputs on it. So that just goes through the list for me and finds any of those. So channel DO0 will be the light we're gonna make blink. So I go ahead and select that. Now if I want to blink the light, another thing I can do here is we have an oscillator block, which will just set it high and low alternatively. And then if I select this whole section and create it as a subsystem, then I can add if I go up here and search for trigger, I can add a trigger block and actually set it up so that this particular block will, if I do it properly, if I drag it over, I can set it so this block will run on a function call. And so now if I navigate back up, this particular subsystem can run whenever this is called. And the way I want to do that is to use one of the time trigger blocks from the LHP block set. And once I've connected up the time trigger, I can choose how often I want it to run. In this case, it's going to be pretty slow, so that we can actually witness the blinking. So let's go for like half a second. So half second on, half a second off. Now I could go ahead and build this, but there's one other problem that we've neglected, and that is that the DIO pins on this actually can be input or output. So we need to actually configure the channel. Configure the channel as an output. So again, if I search on direction register, so for port 0, 1, 2, and 3, I could set the data direction. And so in this case, it says here for an output, I need to be a 2. So I need a constant block. And let me connect that up and then change this to 2. And if I don't inherit from backpropagation, it's going to give me a data type problem. So I'm going to tell it to do that. So now it'll match the data type that it needs. And actually I want to put this whole thing in a subsystem and execute it only at startup. So again, I need the trigger block, which is down here. And I want to set it up to trigger on a function call. And then at startup, in order to do that, let's go back to our LHP block set. So we have some other trigger options. There's startup and shutdown and interrupt and can interrupt. So we want to connect this up as startup. So that means this will execute before it starts the periodic tasks. So the first thing we're going to do is set the output channel as an output, and then every half a second we're going to toggle that. So if I want to, I can go ahead and, well, save this model, and I can just hit Control B to start the build, and you can see the diagnostic viewer is telling me, that I need to set my step solver. So if I go here to Model Configuration Parameters and set it up for a fixed step, that should resolve that problem. Let's try Control B again. So now it's generating the C files, that it's going to compile it. Well, it already is now asking me to connect to the hardware. So it's asking for my credentials. You could put in a password to protect your hardware from any unauthorized use. So anyway, it's generated the C files, compiled it down into a binary. It's transferring it to the hardware, and it will automatically tell it to start up here in just a second, and you'll see the light start to blink at that half a second rate. So now, as you can see, the light is blinking. I deployed the model down onto the hardware, and you can take this concept and just keep going with it. You could build the models in the example workbook and then extend that by adding your own hardware to the I/O and do as much as you want.